All right, new section right here, which is called polar graphing. It's actually a new coordinate system that we're going to take a look at. You can see the top of the notes. What I have is really just review. I have 5 points, just going from 0 to 90 degrees in the unit circle. And I'm going to relate the rectangular coordinate system is the only thing that we've dealt with. And in a rectangular coordinate system, right, we graph it, we give the location of any point, coming up with the x value and the y value. So the x value is just the value that goes to the right of the origin. So here it would just be 1. The y value, I don't go up, so it's 0. Right? Again, this is just review for you. When we drew the right triangles, if I drew this right triangle, this vertical distance was a half. This horizontal distance right here was √3/2. And then all these right triangles, the radius, since it's the unit circle, was 1. All right? So, again, it's just a review. What we're going to do is, when we change the rectangular coordinate system, we're going to get these same 5 points, but we're not going to use x and y. We're going to get that same location, but instead of using x and y, we're going to replace it with r and theta. So if I move down in the notes, okay, saying how to plot points in the polar coordinate system. Okay, you guys can take this down. So what's in blue, how do we plot points in the polar coordinate system? The x and the y are now replaced with what's called r and theta. So r is the distance from the origin, and theta is the angle between the side and the origin. So the angle is really going to kind of give us the location. The radius is going to give us how far that point shoots out from the origin. All right. Now I even give you a little sneak peek. I'm not going to get to this yet, but if you look, this right here, this is the polar coordinate system. Okay. Application of it is radar. It really looks like radar. If you read anything off of radar, if you put a point, you would read radar saying, all right, how far is this from the origin? And you would just count the circles. And then you would give the location by the degree measure, which we'll use degrees or we'll use radians. All right? So that's kind of where we're going. So to kind of look at the example of the unit circle, I'm going to take all of these points in the unit circle, and now I'm going to change these from x and y and use r and theta. So I'm just going to move this over. So here's kind of the connection here. I'll make this even a little bit bigger. So the polar coordinate system, I'm going to get these same 5 points, but instead of recognize them as x and y, I'm going to represent them as r and theta. Now, all of these points, they're all on the unit circle. So all these distances, like from here to here, that's the radius is 1. These all represents radii, which is really the hypotenuse when I drew the right triangles. All these distances are 1 right here. They're all 1 unit from the origin. So the first value is 1 for every single one of these. So we took care of that. And then theta, well, that's just the angle, right? So when I got the coordinates for the unit circle for the rectangular coordinate system, I got x and y. Now here, I just put here, well, the angle 0. Now I'll put this in, looks like I have it in radians, pi over 6, or you could say 30 degrees, pi over 4, or you could say 45 degrees, pi over 3, which is the same as 60 degrees, and this is pi over 2. All right, so these 4 points, they are exactly the same location as all of these points right here. But we just represent them in a different way. So the x and the y, we're going to replace them now. Sorry about this. We're going to replace these points now with r and theta. This is what we're going to replace it with. Okay? Now the last thing I'll put in here, in this where it says how to plot points, we could actually represent the radius as positive or negative. We'll say if r is greater than 0, then we'll say p is on the terminal side of theta. All right, in most cases, you're going to see the radius is positive. Now, if we make the radius negative, if we say the radius is less than 0, then kind of think of it as being opposite. All right, think of the unit circle. If you're on a circle and you want to go the opposite way that you're in the circle, you go 180 degrees. So we're going to say p is on the terminal side of, we will say theta plus pi, or theta plus 180 degrees. Right? Remember we say if you pull a 180, you go in the exact opposite direction that you're at in the circle. All right, so this was just a quick intro right here. Here's the main thing. These x and y values here, we're going to get the same points, but we're going to replace them with r and theta.